Somewhere in the world right now, a foundation is failing. The ground beneath it is loose sand, not bedrock, not compacted soil, sand. The kind that shifts under load, liquefies in an earthquake, and has swallowed seawalls whole. A contractor quotes $80,000 to stabilize it. The fix is cement injection. It works. It also contaminates the groundwater, costs millions per mile, and feeds the single industrial process responsible for 8% of the world's carbon emissions. There is another answer. Run a mild electrical current through that sand, and it becomes stone. No heat, no cement, no contractor, no factory. The process is peer-reviewed, published, and already working in laboratories right now. And somewhere on the Texas border, a woman already figured out the low-tech version of the same principle. She used it to build 600 homes. No mortgage, no energy bill, no permission from anyone. That story comes last. Start with the sand. Sand is the second most consumed natural resource on Earth after water. It is the primary ingredient in concrete, glass, and asphalt. Every bridge, every highway, every apartment tower you have ever seen was built with it. The modern world is made of sand that has been processed, bound, and hardened into something that holds. The problem is that loose sand holds nothing. It shifts under load, it erodes under wave action. It liquefies in an earthquake and swallows whatever was built on top of it. The standard engineering fix is cement injection. Pump liquid cement into the ground, let it harden, stabilize the sand from within. It works. It costs $70 or more per cubic meter, millions per mile of coastline, and it leaves a permanent chemical change in the ground beneath you that no future engineer can undo. The larger problem is what cement costs the planet. 8% of global carbon dioxide emissions, more than aviation, more than shipping. And unlike those industries, there is no clean version. The carbon is not in the fuel. It is in the chemistry. You cannot electrify a cement kiln. The carbon dioxide is baked into the reaction itself. The ocean solved this problem 500 million years ago. It just took one engineer to ask why we had never copied it. The White Cliffs of Dover are 110 meters of solid chalk rising straight out of the English Channel. No kiln built them, no factory, no cement. Marine organisms built them, grain by grain, over millions of years, using nothing but seawater and chemistry. The Great Barrier Reef works the same way. So does every oyster shell on every beach on Earth. The mineral is calcium carbonate. It grows. It has always grown. The ocean has been producing load-bearing stone from dissolved minerals and electrical chemistry for 500 million years without a single carbon emission. That same mineral is the Colosseum. It is the Pantheon. It is every Roman arch still standing 2,000 years after the people who built it are gone. Alessandro Rotoya grew up in Italy, surrounded by those structures. He became a civil engineer at Northwestern University and arrived at a question most engineers never think to ask. What are those things actually made of? And can we grow that material on purpose? The answer was sitting in the scientific literature since the 1980s. Documented, understood, and completely ignored. Nobody had asked what it could do to sand. Rotoya asked, "The experiment is simpler than it sounds. Take sand, saturate it with ordinary seawater, the kind that exists in unlimited quantities along every coastline on Earth. Insert electrodes, apply a low electrical current, too weak to feel, too weak to see. The current changes the local chemistry around the electrodes. It raises the pH of the water. That shift causes the minerals naturally dissolved in seawater, calcium, magnesium, bicarbonate, to stop being dissolved and start being solid. They precipitate, they crystallize. And because sand grains are present, those crystals form in the spaces between them. Each crystal bridges one grain to another, then thousands, then millions. The minerals grow around and between the grains like mortar, except the mortar was never mixed and never applied from outside. It grew from within. Loose sand becomes load-bearing stone. No heat, no cement, no carbon dioxide, just electricity, seawater, and time. Then the detail that stops people. It is reversible. Reverse the polarity and the minerals dissolve. The stone becomes sand again. No contamination, no residue. A permanent material change that is not permanent at all. Cost per cubic meter, $3 to $6 versus $70 or more for cement stabilization. A 15-to-1 ratio before you have broken ground. Over 40% of the world's population lives in coastal zones. Erosion is accelerating. Seawalls that cost millions of dollars per mile are sinking into the same sand they were built to protect. The sand beneath them liquefies under repeated wave action, and the walls go with it. Electrochemical solidification offers a different model entirely. Instead of building a wall on top of the sand, you harden the sand itself. No imported materials, no heavy equipment. Electrodes installed in the seabed, current applied, and the coastline stabilizes from within. Foundation work on loose ground. Stabilize it for construction. Reverse the process when the structure is complete. No permanent chemical change left behind. But the coastal application is the small version. The real target is the $300 billion global concrete industry. Rotoya is working directly with SEMX, one of the largest cement producers on Earth. The proposal is specific. Most major cement plants sit on coastlines. Install modular electrochemical reactors at those plants. Feed them captured carbon dioxide and seawater. Run the current. The reactors grow calcium carbonate aggregate that replaces mined limestone in the plant's own concrete production. The plant that was emitting carbon becomes a plant that sequesters it, locked inside the material it sells. One process, 3 outputs. Carbon negative aggregate, sequestered carbon dioxide, and clean hydrogen gas released as a byproduct. The same fuel governments are spending hundreds of billions to produce. Here it is a side effect. The obstacles are real and worth stating honestly. Scale is the first one. Electrochemically solidifying a stretch of beach or a construction foundation is achievable right now with current technology. Producing enough mineral aggregate to meaningfully replace 4 billion tons of annual concrete production is a decade-long project minimum. The material works. The volume does not exist yet. The second obstacle is carbon dioxide concentration. The process works at atmospheric levels. It works 300 to 700 times faster when co-located directly with an industrial emitter. A cement plant exhaust stack contains 14 to 30% carbon dioxide. The open atmosphere contains 0.04%. The technology needs to be built next to the problem it is solving. The third obstacle is building codes. No structural standards exist anywhere on Earth for electrochemically treated sand or grown mineral aggregate. Cross-laminated timber was developed in Austria in the 1990s. It did not appear in the International Building Code until 2015. 20 years of testing, 20 years of committee meetings, 20 years during which the technology existed and the industry could not use it. Electrochemical materials will face the same timeline. This is not obstruction. It is the system working exactly as designed. Buildings fall when materials fail, but the climate does not operate on a committee timeline. 8% of global emissions is not a problem that waits for the next standards revision cycle. The science is peer-reviewed, the partnership is active, the material exists. The only variable is speed. Simone Swan arrived on the Texas-Mexico border in 2008 with no contractor license, no government program, and no mortgage lender. She had Hassan Fathi's methods and a conviction that the families living in Presidio County did not need permission to build a home. These families earned $8,000 to $12,000 a year. Every conventional housing option was priced beyond them. Her method was the same one that kept Taos Pueblo standing for 1,000 years. Dig local clay, mix it with sand and straw, press it into wooden molds, dry it in the sun. Stack the bricks into 18-inch walls with no rebar, no Portland cement, no contractor, and no mortgage attached to the finished structure. The thermal mass of those walls keeps interiors at a stable temperature through 100-degree summers and freezing desert nights. No furnace, no air conditioning. Physics alone. Material cost per finished home, $800 to $1,500. Energy bill after move-in, 0. 600 homes since 2008. Texas building authorities cited her 3 times. She continued building under the owner-builder exemption and never stopped. The connection to Ratoya's process is direct. Swan proved the material logic. Walls built from the ground they stand on, lasting centuries, owing nothing to the industrial supply chain. Ratoya's electricity extends that same logic to any sand on Earth. No clay required, no sun required, just current, seawater, and the same chemistry the ocean has been running for 500 million years. Come back to the construction site. The contractor's quote was $80,000. The electrochemical process costs $3 to $6 per cubic meter. The mineral is the same one that built the White Cliffs of Dover, the Colosseum, and 600 homes in the Texas desert. The science is done. The process is peer-reviewed. The material exists. What is not done is speed. The coastlines are eroding now. The cement kilns are running now. The obstacle was never engineering. It was a system that cannot profit from a material the ground provides for free. The chemistry is solved. The sand is waiting.